Hello folks, this is the third and final video for the section of Unit 3 on balancing redox equations. In this video we're going to use the algorithm presented in video number 1 to balance the follow reaction under basic conditions. NH3 aqueous plus OCl- aqueous gives us chlorine gas plus N2H4 gas. In the first step, we have to separate the reaction into the two half reactions, and we base these two half reactions on what species are getting oxidized or reduced. You can see here that the nitrogen will be changing its oxidation state, and so will the chlorine. In step 2a, we have to balance all non-oxygen and non-hydrogen elements. In the first half reaction, we need to put a coefficient of 2 in front of the ammonia to balance for the two nitrogens and N2H4. And in the second half reaction, we need to put a coefficient of 2 in front of the OCl- to balance for the two chlorines and chlorine gas. In step 2b, we now need to add waters to the sides of the reactions that are deficient in oxygen. In the first half reaction, there is no oxygen on the reactants or the product side, so this step is not needed. But in the second half reaction, we need to add 2 waters to the product side to balance the 2 oxygens found in the OCl-. In step 2c, we now need to add H+ to balance out the hydrogens. In the first half reaction, we need to add 2 H+ to the product side because in this first half reaction, there's only 4 hydrogens in N2H4, but there are 6 hydrogens with the 2 ammonias. In the second half reaction, we need to add 4 H+ onto the reactant side because there are 4 hydrogens in the 2 water molecules that were added from step 2b. With step 2c continued, we now need to neutralize the H+ with OH- since we are in a basic solution. In our first half reaction, because there was 2 H+ added to the product side, we now need to add 2 OH- to the product side to neutralize it. And to keep this half reaction mass balanced, we must also add 2 OH- to the reactant side. Now this 2 H+ and 2 OH- can be combined to create 2 water molecules. In our second half reaction, we add 4 OH- to the reactant side because there was 4 H+ on the reactant side. To keep this half reaction mass balanced, we now need to add 4 OH- to the product side as well. And the 4 H+ and 4 OH- can be combined to create 4 H2O. In step 2d, we now need to add electrons to the side that is going to be more positive. In the first half reaction, we need to add 2 electrons to the product side because both water and N2H4 are neutral, whereas the 2 OH- on the reactant side gives this side an overall charge of -2. In our second half reaction, 2 electrons are added to the reactant side to balance out the charge. There's only a charge of -2 initially on the reactant side, but a charge of -4 on the product side. At this step, you must make sure you've got electrons on the reactant side for one half reaction and electrons on the product side for the other half reaction. In step 3, we need to make sure that we multiply each half reaction by a certain integer to cancel the electrons, but since both half reactions have got 2 electrons, we can just multiply both of these half reactions by the number 1. Finally, in step 4, we add the 2 half reactions up and we cancel the duplicate species. Please don't forget that to get full credit, you must include all states. As a final step, I will leave this to you. You can prove that both sides of the reaction are charge balanced, -2 charge on both sides. This concludes the video